Previously, we saw how ISPs can block websites by acting as a DNS provider. So when you want to access a website, you ask them what's the website's address, and they give you a fake address, so you can have a look at the website. That is a pretty easy way for them to do it because there's very little computation power involved. But there's another new method of blocking websites which makes use of DPI, or deep packet inspection. So as an example, packets look like this. You have network transactions going on all the time of different protocols and different types of network communication, and all of this happens through your ISP. So this is your computer, and you want to connect to Facebook, YouTube, whatever. It doesn't matter. It has to go through your ISP. Your ISP could be your local cable, like your internet provider via cable, or your mobile data provider. But they are the ones who connect you to the internet. So all of this traffic goes through them. And if they're willing to expend the computational power, they can go through all of those packets. And that is how another type of blocking works. So with deep packet inspection, you can block websites based on unsafe DNS queries, or even if a website has HTTPS, it can be blocked. So of course, if you use your ISP's DNS server, they can block anything. But say you're a bit smarter, so you use Cloudflare's DNS server. So Cloudflare has the DNS server 1.1.1.1, right? So let's say you use this. I'm going to first quickly run a command which will clear my DNS cache. Okay. Now let's filter only DNS packets. Okay, and let me restart this. Okay, so now we're only capturing DNS packets. So let's say example, let's just do a simple ping request to google.com, right? Now you can see there's a DNS query to 1.1.1.1 Cloudflare server, which says, give me the IP address for google.com. And then Cloudflare responds to me saying, the IP address is 216.58.207.238. We see in our command prompt, that is what we got, and that's what we're trying to connect to. Let's do one more example. Okay. Facebook. All right. You can see now we have a query, facebook.com. The IP address for Facebook is this, and that's what we connected to. A ping is just a simple command to check if a website is online or not. But here you can see how typing in a domain name made the query to the IP address. And these are packets that your ISP can see. So this stuff going on is exactly what can be seen by your ISP. They can see this, there's no doubt about it. I mean, unless we're not considering using VPNs right now, okay, just normal internet traffic. They can see this kind of stuff. So let's take a look at the packet itself. The raw packet is this in hex, but it's basically a query saying, I have a question, and my question is google.com. I want to know its IPv4 address. There's an IPv6 address, which is AAAA, but right now we're only using IPv4. So give me google.com's IP address, right? We ask that to the destination, Cloudflare, and we get a response. The IP address for Google is, right, and the answer is this, 216.58.207.238. Now, we're not using the ISP as our DNS server anymore. We have Cloudflare, but the fact is this packet goes through our ISP. So we ask them, so let me add Cloudflare here. Cloudflare. Okay. So through our ISP, we ask them, and then Cloudflare replies. Now, because DNS is not encrypted, Cloudflare can see this stuff. They can see the websites we're asking for. Sorry, the ISP. Our ISP can see the websites we're asking for. Okay, so what that means is if they want, they can manipulate this data. So let's say the response comes in, right? This response, Google is this IP address. If they're willing to put in the computational power, they can check if a packet is a response for google.com, change the IP address, and then this would be something else. Or they could say, if I'm asking a question, what is the IP address of google.com? Don't reply. So I would never get this response. So the man in the middle who can see all of my queries, right, my DNS queries, can say, hey, is he asking for, let's take an example of a torrent website. So asking for Pirate Bay, don't reply. And then we'll never get the answers, so we won't be able to access the website. So this is technically a flaw in DNS, that it's not encrypted. And the solution to that is a secure encrypted form of DNS known as DNS over HTTPS, right? But is HTTPS secure? Yes and no. So when you connect to a website with the HTTPS, what happens is whatever you're communicating with the website, that is safe. So let's take another example, right? So let's say you go to google.com or Facebook, right? Let's say you go to Facebook over HTTPS. Now, if you enter your email and password, right, this data will be encrypted. So if I was to check the data here, I will not be able to see the email and password. So the ISP cannot see the email and password. They cannot see this. If you're a bit unclear about this, you can also check out my other video on encryption. It covers this in much more detail. But okay, this data is safe, but what's not safe is the website you're connecting to. The name of the website is still available in plain text. Okay, now to take another example of HTTP. So we're going to cover, we'll see how HTTP is insecure. So we're going to open up an example website on HTTP. Okay, you can see it says not secure, and this is what we see. Now let's see what the ISP can see. Okay, so we have a HTTP request here saying request get the index from example.org. So this is from us to example servers, and we have a response. And if you see the response, it's the entire HTML source of that website. In fact, I'll show you in Chrome. If I click view page source, right? You see this example domain, body, div. It's exactly what we see here. So this means that your ISP can see exactly the information you're exchanging with a website if it's on HTTP. So HTTP is completely insecure. If it was HTTPS, it's a bit more secure. Okay, now we're going to check out HTTPS traffic. So I've filtered it to TLS, which is the protocol for HTTPS. And let's open a website, say Pirate Bay on HTTPS, okay? So if I enter that, okay, I can see this page. I see the green lock, it's secure. Let's open it up in Wireshark and, okay. So we have different parts of the protocol here. We have a client hello, server hello, and then you see a lot of application data. So in the client hello, okay, let me see if I can find it here. Client hello, there's a lot of information, some random numbers, session ID for security and stuff. But the biggest problem is there's an extension, the server name, and that has the name of the website we tried to visit, the piratebay.org, and this is in plain text. So anyone in the middle, including your ISP, can see this, right? So say again, we're back to this situation. If they can see the name over here, they can see this, then they can block it, right? So that's the problem. HTTPS is secure after that. So after the client and server exchange the keys, see this thing called application data, and that's encrypted. So whatever happens next it looks like garbage. No one can tell what it means. That's the whole point. So although the data afterwards is encrypted, the server name itself is not encrypted. And therefore, someone can tell which website you're connecting to. And the problem with that is, with that information, they can check which websites you've connected to or to block websites. So, for example, the client hello to piratebay.org. Your ISP in the middle could just drop it. They could just say, you know what, we don't want this. So client hello, they will never pass it on to the Pirate Bay. Let's say this is the Pirate Bay, right? It will never reach here, or if it does, the response will never reach. So that is somewhat of a flaw in HTTPS, which is that the name of the website that you're connecting to is leaked. Although the data is not leaked. This stuff, what I typed here, is secure. The response is secure. No one else can see this. No one else knows what I typed. But what they do know is that I connected to the piratebay.org, or I tried to connect. And based on this, based on the packets I'm sending out, remember the ISP can see all of this. They can block the connection. Okay, so now let's check how in Firefox we can prevent this. So I'm going to flush my DNS cache just to ensure that nothing is in there, and we can log all DNS requests. Let's open up piratebay.org. Okay, you can see the lock, it's secure, Pirate Bay. Now, okay, there's a few different requests. Let me see. Okay, so this one, sorry about that. This one you can see is for some Mozilla website. This is the one we're interested in, which is the one for Pirate Bay. Now, I don't know that for sure, but I'm assuming. And if you see, you can't see the name anywhere. And if I scroll to the bottom here, there's an extension called encrypted server name and the encrypted SNI. So what that means is the person in the middle, your ISP, cannot see the name anymore, right? They cannot see the server name. This is not available. Now what they see is an encrypted SNI and an encrypted server name. So they can see you're trying to connect to a website. They do not know that you're trying to connect to the Pirate Bay. So this is how it secures it a little bit more. And it also, in Firefox, if you configure it correctly, it does not make any DNS, any public unencrypted DNS requests. So you can see in DNS, I only have this random Microsoft thing. Well, let me open up a random website as well. So, a website. So .com, you can see that one didn't come up here. But if I was to say use ping or something, right? Ping randomwebsite.com. You can see there's a request. There's a query to this website. Your ISP can see this query. But the DNS queries made via Firefox configured correctly do not show up. They're encrypted, as is the server name identification. Now, it's important to keep in mind that the encrypted server name and the encrypted SNI is a new standard. It's not supported by all websites yet. By default, all websites on Cloudflare support it, but there are websites for which it will not work. For example, Twitter does not support encrypted SNI, but Twitter is not blocked yet. So if a website is blocked so let's summarize a bit. So deep packet inspection. The ISP can see DNS queries, what website you're trying to visit, HTTPS server name indication, which is also what website you're trying to visit, what website you're visiting. And what they cannot see, the information you're exchanging with the website. They cannot see what you're searching for, what the website is sending to you. They cannot see that. All they see is, as an example, the piratebay.org. That's all they see. And they know that, okay, we want to block this website. So right there, when they see the TLS handshake request or the DNS query for the piratebay.org, they will just drop the packet. They won't send it to its final destination, and you'll never get a reply, and you won't be able to connect. However, using DNS over HTTPS, and big if, the website supports ESNI, then with a configured browser, you can access it.